Why are immense computational resources needed for CNN training? Imagine trying to teach a computer to recognize images or understand patterns in data. It sounds simple, but behind the scenes, it takes a lot of work. When training convolutional neural networks, or CNNs, the process demands huge amounts of computer power. Why is that? Well, CNNs are made up of many layers, like convolutional, pooling, and fully connected layers, that all perform complex math operations. These operations include convolutions, which help the network find features in images, and matrix multiplications, which combine information from different parts of the data. To train a CNN, the computer has to do these calculations repeatedly on large datasets. This process is called backpropagation, where the network adjusts millions of weights and biases to improve its predictions. Each time the network makes a guess, it compares it to the actual answer and updates itself. This cycle happens thousands of times, requiring countless floating-point calculations. Memory is another big factor. The network needs to store all its parameters, which can be millions of numbers, plus intermediate data called feature maps that show what the network has learned at each layer. These feature maps can be large, especially for high-resolution images. During training, the computer must keep all this information in memory to perform calculations efficiently. The size of the dataset also matters. Larger datasets mean more data to process, which increases the demand for memory and processing power. To handle all this, training CNNs often relies on specialized hardware like graphics processing units or tensor processing units. These devices are built to perform many calculations at once, speeding up the training process. Even with these powerful tools, training a large CNN can take days or weeks. For example, training a complex CNN on a dataset of millions of images might require hundreds of graphics processing units working together for several days. This can cost thousands of dollars in hardware and electricity. In the world of artificial intelligence applications like ChatGPT, DALL-E, or Midjourney, the need for such massive resources is clear. These models learn from huge datasets and need a lot of computational power to do so. This allows them to recognize images, generate new visuals, or understand language better than ever before. But it also raises questions about energy use and environmental impact. That's why researchers are working on more efficient algorithms and hardware to make training these models less resource-intensive. So, the reason CNN training needs such immense computational resources is because of the sheer number of calculations, the large amount of data, and the complex architecture involved. All these factors combine to make training deep learning models a demanding task, but one that results in powerful AI tools that can do incredible things.